What's up, Chem Peeps? What in the heck are we gonna do? I don't know, but I can't wait! We're going to explain how the solubility of a substance can be understood in terms of chemical equilibrium. Breaking it down as always, let's get to the nitty gritty. We are going to predict whether a precipitation reaction will occur by comparing Q to K, or actually K to Q because that nifty alphabetical trick. So, what causes a precipitation reaction to occur? A precipitation reaction, or precipitate, will form when the concentrations of the ions exceed the solubility of the ionic compound. Now, to determine that, we're going to be doing a bunch of comparisons between the reaction quotient Q and our equilibrium constant K. And based on that comparison, we'll be able to determine if precipitation will occur. When KSP is greater than Q, equilibrium must be established by shifting right to increase the concentrations of the ions. Precipitation will not occur if we're forming a bunch of ions and no solid. So take a look at the example equilibrium set up between cobalt-2 carbonate and its ions. You're provided with the equilibrium constant K, KSP, for this expression. If the conditions were provided indicate that the ion concentrations are less than the ion concentrations at equilibrium, or that K is greater than Q, what's going to happen is our reaction is going to shift right. We're going to use up some solid, form more ions to reestablish equilibrium. However, if K is less than Q, equilibrium must be established by shifting left to decrease the concentration of the ions. Here, precipitation will occur. We will form that solid. So again, come back to the example of the cobalt-2 carbonate. Our KSP expression, if we're given Q conditions in which the concentrations of ions far exceed or are larger than the concentrations of the ions at equilibrium, in other words, K is less than Q, the reaction is going to shift to the left. We're going to use up some of these ions to form some solid cobalt-2 carbonate. In other words, we're going to form a bunch of precipitate, a bunch of solid. And then finally, if K is equal to Q, you're at equilibrium. Precipitation is not going to occur. The rate of formation of solid is already equal to the rate of formation of ions. There's going to be no shifting of our equilibrium. Equal. One more problem related to solubility and equilibrium. A solution containing lead-2 nitrate is mixed with one containing sodium bromide to form a solution that is 0.0150 molar in lead-2 nitrate and 0.0350 molar in sodium bromide. Does a precipitate form in the newly mixed solution? First, let's write an equation to describe this reaction. Lead-2 nitrate, and it's going to be aqueous because all salts containing nitrate are highly soluble. One of those solubility rules you gotta know. We mix it with sodium bromide, also aqueous. That sodium ion, dead giveaway for a salt that's gonna be highly soluble in solution. Hopefully you recognize we're setting ourselves up for a precipitation reaction. Double replacement. We're gonna form lead-2 bromide and sodium nitrate. The sodium nitrate, we should know, highly soluble. Aqueous. The lead-2 bromide, one of our less soluble salts, and will be the one that could potentially form a precipitate. I'm going to balance, then I'm going to write an equation that shows the solid lead-2 bromide in equilibrium with its ions. Boom. Our Q expression for this slightly soluble salt, boom. And we're told that once our original solutions are mixed, the solution is 0.0150 molar in lead-2 nitrate and 0.00350 molar in sodium bromide, which means that my lead-2 ion concentration is 0.0150 because the ratio of lead-2 to lead-2 nitrate is 1:1, and bromide ion is 0.00350. Again, because the ratio of bromide ion to sodium bromide, 1:1. Don't forget to square. Quick trip to the calculator. 0.0150 times parentheses 0.00350 close parentheses squared. Enter. Q equals 1.84 times 10 to the minus 7. Now, is a precipitate going to form? Let's compare K to Q. We know that the KSP value for lead-2 bromide is 4.67 times 10 to the minus 6. Boom! And Q, we just solved for, is 1.84 times 10 to the minus 7. Comparing K to Q, K is larger than Q. So our reaction is going to favor the formation of the ions, not the formation of our solid precipitate. In other words, the concentrations of our lead 2 and bromide ions aren't high enough to saturate the solution and start forming a precipitate. The solution can still hold more lead ions and bromide ions. So, to be clear, no precipitate will form. K is greater than Q. If you don't understand, do me a solid. Try rewatching this video or come into tutorials. Have a great day.